You ever wonder how a tiny, invisible vibration on a factory machine can end up preventing a $1 million breakdown? Well, today, we're going to follow the incredible journey of a single data point, from the noisy factory floor all the way to a critical business insight. Okay, let's dive right in.
So, we're going to track our data point through 5 key stages. First, we'll look at the challenges it faces right from the start. Then, we'll see how it picks a sort of digital highway to travel on. We'll watch it hit a major crossroads between being processed locally or centrally. After that, we'll follow its final path into the business itself. And finally, we'll talk about why making sure it's trustworthy is, without a doubt, the most important part of this whole journey.
All right, so our story kicks off right here, in the middle of all the hum and noise of a modern factory. This is where our data point, just a single measurement of a machine's vibration, is born. And let's be clear, this is not just some academic question. This is the multi-million-dollar problem that the Industrial Internet of Things, or IIoT, is trying to solve, every single second of every single day. The stakes really couldn't be any higher. Now, our little data point doesn't have an easy trip ahead of it. I mean, from the second it's created, it's up against some huge obstacles. The factory network, it might have limited bandwidth. Wireless signals, they can be super unreliable. And there's always a risk that the message gets delayed, what we call latency, or just lost completely. You know, on a factory floor, a half-second delay isn't just a delay. It could be the difference between a quick fix and a catastrophic failure. So, to get through this crazy environment, our data needs to choose a path, kind of like a digital highway to travel on. And this choice, it's all about trade-offs. This is where communication protocols come into play.
And you have this really clear choice to make. You can think of MQTT as a super-fast motorcycle career. It's incredibly lightweight and just sips energy, which is perfect when you've got thousands of tiny sensors, many running on batteries. Then you've got HTTP. This is more like a big, reliable armored truck. It's robust, everybody knows how to use it, and it's great for bigger jobs like device management. But it's not nearly as quick for those split-second, time-sensitive messages.
Okay, so our data point has picked its highway. Now it hits a massive fork in the road, and this might be the most important decision it makes. Does it get processed right here, right now, on the spot? Or does it need to take the long trip to a central headquarters for a deeper look? This is really the fundamental choice. Edge computing is the local route. It happens right there near the sensor, and the whole point is immediate action. Think of it like a reflex. The cloud, on the other hand, is the central route. Your data travels to a remote data center for some really deep, large-scale analysis. That's more like the brain's conscious, strategic thinking. So when does the edge win? Well, it's simple. When speed is everything. Processing that vibration data locally means a machine can react to a problem instantly, without having to wait for a message to go all the way to the cloud and back. The edge is also like a smart filter. It can bundle up data and only send the really important stuff onward, which saves a ton of network bandwidth. But the cloud has its own set of superpowers for sure. It's where you go to see the big picture. You can train these massive AI models on years of data from thousands of machines, store information for compliance, and even compare how entire factories are performing against each other. This is really where long-term strategy happens. But here's the really cool part. It's not always an either-or choice. We're seeing these new hybrid approaches pop up. They let you train powerful AI models across a bunch of different locations without having to send all your sensitive raw data to a central cloud. So you really get the best of both worlds, the instant speed of the edge and the deep learning power of the cloud. All right, so our data point has been processed, whether at the edge or in the cloud. And now it's on the final leg of its journey, getting its valuable insight directly to the business where it can make a difference. And this is how it gets from the machine on the shop floor to the manager's dashboard. It starts at the source, right in the machine's control systems. From there, it gets collected by industrial gateways, flows through these digital queuing systems, and finally, it lands in the big enterprise software systems. You can think of these as the central nervous system of the entire business, managing everything from manufacturing to company resources. And why is this carefully managed path so important? Well, because it preserves the data's entire history, its provenance, and the exact time it was created. This gives you a complete, unbreakable audit trail, and that is absolutely critical for things like quality control, traceability, and meeting all those strict regulatory standards. So we've followed our data point all the way from a simple vibration to a major business system. But let's be really clear here. None of this journey, none of the fancy tech, none of the AI, matters one bit if at the end of the day, the data can't be trusted. So, how do we build that trust? This is basically the toolkit. You use automated checks for quality, you have models that can spot weird readings, and you use something called explainable AI. And this is so important. It means the system doesn't just give you an answer, it actually shows its work, so you can understand why it's recommending something. And all of it is backed up by the solid audit trails we just talked about.
At the end of the day, this is the end game. It all comes down to one single, powerful goal: making production decisions that you can literally bet the company on, because you know they're based on solid, trustworthy data that makes everyone happy, from the operator on the floor to the regulator in the boardroom.
And that brings our data point's incredible journey to an end. But it leaves us with a much bigger question to think about. As we hand over more and more big decisions to these intelligent, automated systems, the real foundation isn't the AI or the sensors, it's trust. The ultimate challenge we're all facing is figuring out how we ensure that every single one of their decisions is fundamentally and provably trustworthy.